All right, let's say I want you to give me an equation where the solution was x equals 3 square root of 5. So my question for you here, like essentially you're just working backwards to the equation where this is our solution. My first question is, how do we get rid of the square root? And I hope you'd say, well, I'm going to square that. And I got to do that to both sides. So I get x squared equals, let's see, I square the 3, and that becomes 9. And the squaring the square root of 5, that just becomes 5. So I get x squared equals 45. And more specifically, let's say I want you to put this in standard form. So standard form, remember one side has to be equal to 0. So I can just subtract 45. And I get x squared minus 45 equals 0. And that would be our equation, or a polynomial. So first, let's take a look at this. How many answers? I was only given one solution. But according to the fundamental theorem of algebra, I should have two solutions. So if I know that one of them is x equals 3 square root of 5, can you tell me what the other one would be? And I really hope that you just spoke to me like you would Dora the Explorer. The answer should be negative 3 square root of 5. Because let's just take a look. If I was to go backwards in solving this, so if I have x squared minus 45 equals 0, you know, I can add 45 to both sides, get x squared equals 45. And now, when I take the square root of both sides, x equals, well, that's 9 and 5, 3 and 3. So we get 3 square root of 5, but I'm only halfway correct because I need a plus or minus. Anytime I take a square root, I'm going to have a positive and a negative answer. We call those conjugate pairs. If I could spell. So radical solutions come in conjugate pairs. So let's look at something a little bit more complicated then. So let's see. Write the equation of a polynomial given the following roots. So let's start at x equals 2 and 3 square root of 5. Well, I already have the equation for the x for the 3 square root of 5 based on this little diddly over there. I know that this comes from, so I could say that is an x squared minus 45 is the equation that that piece comes from. Well, how about for the x equals 2? Well, if I have x equals 2 as my solution, I want it in standard form. It's just x minus 2. And now that I have this, I can just distribute. So I get x cubed minus 45x, and we got minus 2x squared plus 90. And of course we want our answer in standard form, and we'll just call this function f of x. So we get x cubed minus 2x squared minus 45x plus 90. Not too shabby? Let's look at another example. What if I have x equals 1, but it's given a multiplicity of 2, and then I have 2 plus the square root of 3. Well, if I have x equals 1, and I want to get that in standard form, I can just subtract 1, so I get x minus 1. But this has multiplicity 2, meaning it shows up twice. So this is like an x minus 1 squared. Well, now let's take a look at if I have x equals 2 plus the square root of 3. And remember, I'm trying to work backwards to get one side equal to 0, but also I don't want radicals. Unless you want to multiply with radicals, which I'm just telling you, don't do it. You don't need to. So let's take a look at this. Well, the 2 isn't causing me any problems, so we can just subtract 2. So I get x minus 2 equals the square root of 3. The square root of 3, I don't want to deal with that. So I would like to get rid of that radical by squaring it. But I have to square both sides. So depending on how comfortable you are with squaring things and perfect square trinomials, vocab, x squared minus 4x plus 4 is what the left side becomes. Square root of 3 squared becomes 3. Well, I still want this to be in standard form. So now I have x squared minus 4x plus 1. There we go. So now when I look at things to multiply together, we'll call this one g of x. I know I'm going to have an x minus 1, multiplicity 2, and an x squared minus 4x plus 1, all of that being multiplied together. Based on what I just did, like from the x minus 2 to the x squared minus 4x plus 4, that's a perfect square trinomial, meaning there's a pattern here. So the x minus 1 squared, that's like x squared minus 2x plus 1. And we're going to multiply that times x squared minus 4x plus 1 to get our final polynomial. And we can do that using multiplication. I'm going to use a little box method because that's what I have room for at this point. And if you just want to distribute like I did in number 1, that's totally fine. So we have x squared minus 4x plus 1, and we have an x squared minus 2x plus 1. So we get x to the 4th, multiply those, negative 2x cubed, x squared, and 4x cubed, 8x squared minus 4x, and now we have an x squared minus 2x plus 1. And now I'm just going to combine my like terms, because our like terms end up on our diagonals, which so convenient. Love to see it. Also, I hope you love to see my color coding, because who am I if I don't color code? So our polynomial is x to the 4th, negative 2x cubed minus 4x cubed is minus 6x cubed. Excuse me while I go color code this. Minus 6x cubed. And now we have x squared plus 8x squared plus 1 more x squared. So in total that's 10x squareds. And negative 4x minus 2x is minus 6x. And then I have a plus 1. Nice. Okay, let's do one more example. So let's say our solutions are going to be 3 and 1 plus 2i. Ooh, that looks a little complex because it's a complex number, in case you didn't get that joke. So, once again, I'm going to look at this 3. I want to put it in, if x equals 3, I want to put that in standard form to get my equation where it came from. So I get x minus 3. Well, if I have x equals 1 plus 2i, you might be thinking, should I do something differently? Well, my question for you is, what does I equal? I is a square root. Oh, I is the square root of negative 1, meaning I can do the same process that I just did with the radical. I know that I'll have a conjugate pair, so I'll have another conjugate solution. And, ooh, linear factorization. I'm putting that over here so I remember to talk about it at the very end. Factorization. Okay, so we're going to start by subtracting 1. So x minus 1 equals 2i. And once again, since I is a radical, we're going to have to square both sides to get rid of that radical. I know that if I was to distribute that, that's x squared minus 2x plus 1. Okay, 2i squared. Well, the 2 squared is going to be 4. Then I get that. Well, if I was to square a square root, that would just get rid of it. So I squared is actually negative 1. So that's real important. So it turns out x squared minus 2x plus 1 is 4. This is like 4 times negative 1. So that's negative 4. So I get x squared minus 2x plus 5 is 0. So now I have my pieces. We'll call this function h of x. So I get x minus 3 multiplied by x squared minus 2x plus 5. And I'm just going to distribute it this way because I want to. So I get x cubed minus 2x squared plus 5x. And I'm going to go this way. Negative 3x squared plus 6x and then minus 15. And now I can just add those together. And I get x cubed minus 5x squared plus 11x minus 15. And there's my polynomial. Okay, linear factorization. Linear factorization would be like if I have solutions 2, 3, and 7, the linear factorization would be x minus 2 times x minus 3 times x minus 7, meaning all of our factors are linear, and that's what we got. So for this one, we know we have an x minus 3, and because it has to be linear, I want you to take note of this little friend right here. If that's not linear, that's quadratic. So we need to be utilizing this. So we have x, and it's going to be minus, and then 1 plus 2i. But as a reminder, that only represents one solution. This should be 2 because it comes in a conjugate pair. So the conjugate pair of 1 plus 2i, well, it's just the plus or minus in front of the radical that switches, so it should be 1 minus 2i. So we go x minus, and then 1 minus 2i. So now you can simplify that. So we get x minus 3 times x minus 1 minus 2i, and x minus 1 plus 2i. And that is your linear factorization.